previously you learned about simple probability, which is what happens when there's one event. And we talked about simple probability in regards to sample space and actually finding the probability, but today we're going to dive into compound or multi-step probability. Compound is going to be a word that you'll see more so in high school. I might be using multi-step probability more often because when we're doing multi-step probability, we're actually going to be multiplying. So it'll help us kind of connect the two. Now there's two different types of questions that you could be asked. You could be asked how many. If you're asked how many, you're going to use a method called the fundamental counting principle, and your answer will be a number. You may also be asked, what are the possible outcomes? If you are asked specifically to name the different outcomes within a multi-step event, we're going to use the sample space in 3 different ways, and you get to choose one of the 3 different ways. You can choose to do a list, a tree diagram, or a table, and I'm going to walk you through all 3 methods, and they're just little tricks to help you find the sample space of a multi-step probability. Counting principle. First, we want to address what happens if they ask how many different outcomes are there. The first question says you have 5 shirts, 3 pants, and 2 pairs of shoes, and how many outfits can we make? So we see this keyword, how many. So we're going to take all the different categories, shirts, pants, and shoes. We have 5 shirts, we have 3 pairs of pants, and we have 2 pairs of shoes. And because there's multiple events going on, we've got multiple things we're looking at, we're going to multiply. 5 times 3 is 15, 15 times 2 is 30. So there are 30 different outcomes in this scenario, 30 different outfits. The next one's going to look a little different. We want to find out, we flip a coin 3 times, and so how many different outcomes are there? And it's a little different because we don't have the categories like what we did before. Before we had shirts, pants, and shoes. But that's okay, we can still do it. How many times are we going to flip the coin? We're going to flip it 3 times. So we've got a space 3 times. When you flip a coin, you're going to get a heads or a tails, no matter what happens. So we've got 2 different possible outcomes. Again, whether you flip it 100 times or 1 time, the next time you're still going to get a heads or a tails. So you still have 2 possible outcomes, even if you flip it a 3rd time too. We've got multiple events going on, so we're going to multiply, and we end up getting 8 different outcomes. Now, diving into sample space. First, we're going to focus on a list. The problem here says we have a purple shirt, a green shirt, and a white shirt, and you also have blue and khaki pants, and we want to know how many different outfits can we make. The keywords here is what are. It doesn't say how many, so our answer is not a number. We want to list, in this case we're listing all the different types of outfits that we could have. So we've got a purple shirt and blue pair of pants. We've got a purple shirt and a khaki pair of pants. And you're just going to continue to list it. We have a green shirt and a blue pair of pants, green shirt and a khaki pair of pants, white shirt, blue pair of pants, white shirt, khaki pair of pants. I know it's weird, but that's your answer. You've listed all the different types of outfits that you can make from what's in your closet. Now, if it then asks a follow-up question with how many, you would just count, and there are 6 different outcomes. So you will possibly be asked that in the future, both what are they and how many are there. So you do need to know how to interchange between the 2. Next, we're going to focus on tree diagrams. The first part, the first question says you flip a coin 3 times. So there's 3 events going on here. So we're going to continue our tree diagram into 3 different branches. When you flip a coin, we've got a heads or tails, and that's our first event. Now, I don't care if you get a heads or a tails the first time, it doesn't matter. If you flip a coin a second time, you're still gonna get a heads or a tails. So we're gonna continue a branch off of each with all of the possible outcomes. Flip a coin 2 times or 100 times, doesn't matter. The third time you flip it, you are still going to get either a heads or a tails. So you continue the branches. And as weird as it is, if it specifically asks for a tree diagram as your answer, then you have found your sample space. Now we have learned in a previous slide that if you flip a coin 3 times, we're gonna have 8 different outcomes. This one asked for the sample space, so our answer shouldn't be 8. But if you're then asked a follow-up question, how many different outcomes there are, you do need to know how to interpret this and be able to read a tree diagram. So you follow the branches down to find all of the different possible outcomes. So this would be flipping a heads 3 times. This would be flipping a heads twice and then a tails. And you follow along all of the branches, and essentially however many different branches that you end with will be the total number of outcomes. Next question. You have a red, white, and blue marble. You draw one, you put it back, and then you draw another marble. So there's 2 events going here because you're drawing a marble twice. Now you do have to be careful because here we're putting the marble back, but there might be other problems you'll see in the future where you don't put the marble back. So you do have to be careful with the wording. Now we've got 2 events, so we're gonna continue the branches out twice. The first time you could get a red, white, or a blue. Then you put the marble back. If you pull a red, you're gonna put it back, and then you reach into the bag again, and again, you could get a red, white, or a blue marble. If you pull a white marble, you put it back, and again, you could get a red, white, or blue marble, and so on. That is your answer. Again, if you're asked for how many different outcomes are there as a follow-up question after being asked what the sample space is, you would count, and there are 9 different outcomes. Last way that you could list or show your sample space is through a table. Here we're making a sandwich. You are gonna have a sandwich on white bread. That's not gonna change. What changes is based on your meat or cheese options. So you could have roast beef, ham, or turkey, and you could also have American or provolone cheese, and we wanna know how many different sandwich options do you have, and we're gonna make a table. So first, we have a table. And we have 3 different meat options. So we want to split, it doesn't matter whether you do it on the top or on the side because you're going to do the other category on the other side. I'm going to do it on the top because I made it more of an elongated rectangle. And I have 3 different meat options. I have roast beef, turkey, and ham. And I have 2 different cheese options. So I'm going to split this up into our American and provolone cheese options. And then you just connect the categories together. We have roast beef, American cheese, roast beef, provolone cheese. We have turkey and American cheese. We have turkey and provolone. Ham and American cheese, ham and provolone. And these are all the different sandwich options that you could have. If you were to then be asked how many, you count, and there are 6 different sandwich options. Thank you.